Okay, this is the homework help video for Honors Math 3, Unit 6, Worksheet 4, and I'm going to start with question number 11. So for question number 11, the first thing we want to do is rewrite it into descriptive form, so that means I'm going to complete the square. So I am first going to do just a little bit of rearranging here, so I'm going to put my x terms together. And then I don't have another y term, I just have that one, and then I'm going to add the 1008 to the other side. So I'm going to group these two together, so that would be negative 18x squared, and then plus 180x, and then I just have my y term, so 31y squared, and then add the 1008 to the other side. And then from there, I only have to factor out of the x terms because there's two of them and not on this one. So I'm going to factor out that negative 18. And then, so when I divide this by negative 18, remember that will turn negative as well. And then I'm going to complete the square only on the x term. So that will give me negative 18, and then x minus 5 squared. And so to this side right here, I added negative 5 squared is 25, and then 25 times negative 18, using my calculator for that, is negative 450. So on this side of the equation, I added negative 450, so I have to on this side as well. So I'm just going to do that underneath here, and then add that to 1008. And I'm using my calculator here, by the way. I'm not doing this in my head. So then that would give me equal to 558. And so when we do these, we want this to be equal to 1, so then I'm going to divide everything through by 558. And then I'm going to reduce that. So and in the process of reducing as well, I'm going to flip the order of this because I want my negative term to be second. So I want it to look like, you know, something squared minus something squared for the hyperbola. So I'm going to put this first. So I'm going to go ahead and reduce that first. So when I divide that, or reduce it, I'll get 18. So then I'll have y squared over 18, and then minus. And then when I divide or reduce this, I'll get x minus 5 squared, and then over 31, and then that's equal to 1. Okay, so then that's the equation I'm going to be graphing. So I'm going to go ahead and copy that over to this page, my graph paper. So I have y squared over 18, and then minus x minus 5 squared over 31, and then equal to 1. Okay, so that's what I want to graph. So then for this here, I want to find my center. So my center is going to be alphabetical order, right? X before y, and then opposite on both. So I look at my x term, so that'll be positive 5. And then my y term, I'm not adding or subtracting anything to the y value, so then that would be 0. And then I want to find my delta x and my delta y, or x radius, y radius. So I'm just going to use x sub r, so my x radius. So then that's going to be what's underneath the x term. So in this case, that would be 31. So I would do the square root of 31. So I have to actually graph that. So I don't know the square root of 31, like in terms of like reducing, it's not a whole number. So I'm going to just use my calculator to get a decimal, and so I get 5.56 or 5.6. And then I want to find my delta y, or my y radius. So delta y, or my y radius. So I look to see what's underneath the y squared term, which is 18, and then I take the square root of 18. So that would reduce, right? So 18 is 9 times 2, so that would be 3 root 2. But again, I don't know how to graph 3 square root of 2, right? Like where, like how far is that moving? So I'm going to change that to a decimal also. And so that looks like it is about 4.2. So 4.24 or 4.2. And then I also want to find my, focal distance, right? Like how far to move from the center to the focus. So that's finding C. And so, hold on one second. So that's finding my value for C. So to do that, I need to use that formula. So C squared. And then that's equal to delta x squared plus delta y squared. So I'm adding the denominators, right? So delta x squared plus delta y squared. So then that would be 31 plus 18 which is 49. So c squared equals 49. And then that's square rooted, so c is equal to 7. Okay, so just about everything there. So now I'm going to go ahead and graph. So let's do that over here. Zoom out just a little bit. So my center is at 5, 0. So here's my center. And my x radius is 5.6, so I'm going to count left and right, 5.6. And then I'm just going to put a line there, right? And then to the left, put a line there. And then 4.2, so I'm going to go up 4.2 and down 4.2. And then I'm going to use those markings to create that box, right? So that box is not really part of the graph. All it's doing really is just kind of creating some guidelines for us so that we can graph it as fairly accurate. So again, the box is not really the graph, right? It's just creating some guidelines for us. So then the diagonals that go through the box, that are what we call our asymptotes, right? So the diagonals as we go through that box, those are our asymptotes. Turn that just a little bit. Okay. So once I get my asymptotes, then I need to decide like which way is the hyperbola going to go. So I see that it's the y term is the positive, right? So this is my positive. So that means it's going to be along the y-axis, right? It's going to run with the y-axis because this is the one that's positive. So then my vertices are here and here. So there's my vertices. So then that means this is my transverse axis. So I'm going to go ahead and draw that one in. So this is my transverse axis right here. And I'll just put a T by that so we remember that. And so then I'm going to graph my foci. So I need to use this value here, c equals 7. So then from the center, so here's my center, I'm going to go along the transverse axis past the vertices and count 7. So 7 up, 7 down. So this was, so mine is off of the page on the top, so I didn't do a very good job of that. So I'm going to drop it just a little bit. And then the bottom go down 7. So right here. And then when I make my graphs, I want to start at my vertices, which is at the end of the transverse axis. And then I want to run towards the asymptotes, right, and then parallel. So these are going to be really wide, right? So really wide hyperbola, and then run parallel to the asymptotes. So I'm going to like kind of turn my paper here just a little bit so I can be fairly accurate. So again, when I sketch it, I want to start at my vertices, which are at the endpoints of my transverse axes, and then run parallel to my asymptotes. So there is my graph. So we also have to find a few other things, right? So we have to identify the different characteristics. So let's go ahead and do that. So I'm just going to do them right here. So my vertices, write those as ordered pairs. So my center was at 5, so my vertices will be at 5. And then I went up my x radius or y radius and down, so that was 4.2 both directions. So I'm just going to say plus or minus 4.2, so a little shortcut there. And then I want to do the same for my foci. So again, we started at 5, which is where the center was, and then we went up 7 and down 7. So because this is at 0, I can just write plus or minus 7. And we have our transverse axis is right here, and then our conjugate axis is this one here. So this is our conjugate axis. I'm just going to put C here. So I'll do the length of my transverse. So that would be the vertical one, right? So we went up and down 4.2, so that length would be around 8.4. And then my conjugate axis is along the x-axis. So I went left and right 5.6, so 5.6 twice would be 11.2. And then my equations for my asymptotes, so equations of my asymptote. So I'm going to write just the equation first underneath it here. So y minus k equals plus or minus the change in y over the change in x. So those are my x and y radius, and then x minus h. So for that then, so that would be y minus, so k is the center, right? So that would be at 0, so that's my y value. So y minus 0. And then equals plus or minus the change in y over the change in x, and that's my x and y radius. So my y radius is 4.2, and then my x radius is 5.6, and then x minus my value for h, I'm looking at my center for that, so that would be 5. And then I want to simplify that, right? Like, because that looks a little weird, so I'm going to do that down here. So y minus 0 is y, and then plus or minus, and then I have that weird decimal, so I want to make that just its own decimal, right? Not a numerator and a denominator decimal. So if I do that divided by that, I get about 0.75 or 0.8, and then x minus 5. And so that would give me my equations of my asymptotes, and then finally my eccentricity, so E. So that is, so we write it as C over A, right? C over A, but C is the distance to the focus, so the distance to the focus. So how far did I go from the center to the focus? And I went 7 units, right? So C. And then A, so A is kind of random, right? So, but that's just the distance to the vertices. So how far did I go from the center to the vertices? And from the center to the vertices, so that was my y radius, so that would be 4.2. So on a hyperbola, our eccentricity should be greater than 1, right? Whereas on the ellipse, it was less than 1. So when I divide that, I should get, so I get 1.67 or 1.7. And that's number 11. Okay, and then let's do one more here. Let's do number 18. So one of the write the equations. So for question number 18, so they're giving us some information here, and with this information they want us to write the equation. So I'm just going to do a little sketch so I can kind of see what we're talking about here. So I'll just do a pretend graph here. So my vertices are at 0 plus or minus 12, so that would be this way. So I guess I don't need to be quite that way. Ah, that's fine. Okay, so over 0 and then up and down 12. So I'm just going to do 0, 12. And then 0, negative 12. And then my foci are at 0, 15, and 0, negative 15. Okay. So then that means my center is at 0, 0. So that kind of makes this nice for that, right? So my center is 0, 0. And then let me put VF and VF. Okay. So my center is at 0, 0, and then I know that the distance to my vertices is going to be my y radius, so then I know my y radius is 12. So right now I know my center, let me scoot this over and zoom in a little bit. So I know my center is 0, 0, right? So this is for number 18. And I know my y radius is 12, because that's vertical, and that's the distance to my vertex. So that would be y radius is 12. So the only thing I'm missing is my x radius. And so I'm just going to use that relationship of how I find c. So I know in general it's like delta x squared plus delta y squared equals c squared, right? So I know my delta y squared, that's my y radius, so that's 12. So 12 squared is 144. And then c squared, so c is the distance to the focus, right? So the distance from the center to the focus, and in this case that's 15, right? So from the center to the focus is 15. So then I'm going to do 15 squared, which is 225, and then just solve for delta x squared. So delta x squared, so subtract 144, and I'm using a calculator here. So that's 81, and so delta x is the square root of that, which is 9. So then that means my x radius is 9. So then now I can set up my equation. So it's nice that the center is 0, 0. So that would just be, and then it's a vertical, right? Whoops, I forgot to mention that. So this is vertical, so that means I need to start with a y. So I'm going to do y squared and then over 12 squared, so 144, and then minus, and then x squared, and then over my x radius squared, so that would be 81, and then equals to 1. And if the center wasn't 0, 0, then this would be like y minus, you know, whatever y value squared, and then x minus whatever x value squared. And so there is my equation. And that's it.